All right, Honors Algebra 2 and Algebra 2. Here is the big video, possibly two videos. Animals in the back make a lot of noise here for your 2.5, 2.8 game plan. All right. Really, folks, I'm not checking this fully until after page 5. So in this case, page A. Now, if you guys didn't do the warm-up for 2.6 or don't have one, then let's just call this the warm-up, evaluate each. So you might have to pause it, write that down in black. There's the answer. Just evaluate. You're gonna do this a lot when you graph the absolute value functions. Again, pause this. If you already have something else, that's fine. Every class kind of did something different. Some classes skipped a warm-up. That's no big deal. And then here's number on page 8. I'm sorry, not page 8. Here's number 8 on page A. All right, next page, page 6 is what we did today in class. Honors Algebra 2, we did it earlier. Graphing a piecewise function, all right? Some classes we made 3 different tables, which I think is important. The first equation, that's the first table, y equals 6. X less than or equal to -1, so let's use -1, -2. Y is 6. Less than or equal to means it's a closed circle. So that's why I have it here, closed circle, and I'm graphing to the left. All right, then the second interval, -1 to 4. Now I know X can technically not be -1 or 4, but it's going to approach. I always use those transition points in my graph. All right, these are all going to be straight lines. 2 points determine a line. So if Y equals 2X is the second equation, plug -1 and 4 in for X, you get -2 and 8. So when I graph those 2 points, a straight line goes through. I have an open circle and an open circle and a straight line between. 4 minus X is the next one. X greater than or equal to 4, so I'm going to use 4. I'm going to use 5. I'm going to plug 4 in, and then 5 in. I'm going to get 0 and -1. I'm going to graph that. All right. Again, it's going to take a little bit of time to get in the hang of these. This next one, y equals 2x, is my first equation. For x less than or equal to -6, so I'm going to use -6 and -7. Those are my y values. Closed circle at -6, -12. You don't really have room. That's my fault there. The graph is going to go further south there. Then -6 and 2, my boundary points for the second equation when y is simply 5. All right, so around -6, 5. Goes in an open circle. It can approach -6, 5, but never technically hit it. Closed circle at 2, 5. And lastly, that's a boo-boo. My last equation is y equals -3x. So if x is greater than 2, I'm going to use 2 and 3. And then I get -6 and -9. All right. 2, -6 is an open circle because of the non-equality parts. Those are examples, some examples we did in class. Here's number 5, one that we did in class. Again, breaking your 3 equations. In Honors Algebra 2, we just put the first 2. This is the first equation, so y equals x plus 6. So plug -5, -6 in for x. Those are your y values. The second equation is y equals -5, and you're going to use -5 and 4 as your boundary points. Y is going to be -5. And then lastly, y equals 2x minus 7 is your equation. You're going to plug 4 and 5 in for x right there and get 1 and 3. That's -5, 1. That's going to be a closed circle. You're going to go to the left. For -5, 5, and 4, -5 in that second equation, both of those have open circle, no equality. And lastly, at that boundary point right here, 4, 1, you have a closed circle. And then 5, 3 is also closed. And that goes up forever. All right, here are then answers to game time questions. Again, that's the first equation when y equals 3, the second equation when y equals x, and the third equation when y equals 7. We did this one in class because at the boundary points, you get at first a closed circle at -3, -3, and then the second equation, you'd have -3, -3 again, it'd be an open circle. But if you put an open circle over a closed circle, it's still going to be closed. So that's how that graph looks. Number 2, your first equation is y equals 2x. Use -3 and -4. You get -6 and -8. Next equation is y equals 1. So that's why we get 1 there. Use -3 and 5. Y is 1 no matter what. And the next equation, if x is greater than or equal to 5, use 5 and 6 for x. Y is x minus 2. That's why you get 2 less, 2 less. Around 3, or -3, -6, open circle, and then going down like that. Then on the next one, negative 3, 1, closed circle. And then that horizontal line ends at 5, 1, which is an open circle. Then we have x minus 2 for x is greater than or equal to 5. That's why you got a closed circle at 5, 3. And then you have 6, 4, and it goes up forever there. Next one, x plus 4. Negative 2 and negative 3, your x values. All right, next equation, y equals 2x minus 3. You're going to plug in negative 2 and 6. Then you have x is greater than 6. You're going to plug 6 and 7 and get 5 in. Again, these are x values you're using for the second equation. Plug it in. X values you're using for the third equation. You still get 5. So at negative 2, positive 2, because of that first equation, less than or equal to, you have equality. Then you have negative 3, 1. You're going to plot. Arrow down like that. Then on the next one, negative 2, negative 7, open circle. Then 6, 9 gets the closed circle. And lastly, if x is greater than 6, so open circle at 6, 5, and graph everything to the right, a horizontal line. All right, these are, I think, definitely the hardest questions in your packet. And we have absolute value functions. The vertex is at 0, 0 always. This is the just the generic. So 0, 0 is my vertex. I go one to the left, one to the left, one to the right. Then another to the right, another to the left of my vertex. And unless they're a negative absolute value of something, they make that V. So number 3, here we go. Again, we should have all seen at least one day of this. Set what is inside the absolute value equal to 0. So 1, 3 is your vertex. Go 1 to the left, 1 to the right. 2 to the left, 2 to the right. When you plug 2 in for x, you get 4. When you plug 3 in for x, you get 5. So you're going to get the same value as when you plug 0 in and negative 1 in. You have that symmetry. Here's what that graph looks like. All right, next page, page 10. Number 5 there, set what's inside the absolute value equal to 0. You get 5. 5 comma 0. Nothing out here on the outside. Go 1 to the right, 6, 1 to the left, 4. Plug in 6, and you get negative 3. So same value as when you plug in 4. Plug in 7, you get negative 6. Same thing as when you plug in 3. As it makes a TP upside down because of that negative 3 on the outside. Here's 6. Set x plus 7 equal to 0. Get x is negative 7. Left with this negative 3. 1 to the left, 1 to the right. 2 to the left, 2 to the right. Plug negative 6 in. Plug negative 5 in. You get negative 1, then 1. Because of the symmetry, those are your values there. Again, whatever you plug, if you're 1 to the left of the vertex, that's the same y value as 1 to the right. 2 to the left of the vertex, same value as your 2 to the right. Same y value, that is. There we go. All right, number 8, set that equal to 0. 3x plus 9, set equal to 0. You get x is negative 3, so make sure that's right. And then the y-coordinate is that 2, positive 2 on the outside. Go 1 to the left, negative 4, 1 to the right, negative 2, 2 to the left, negative 5, 2 to the right, negative 1. Plug negative 2 in for x, you get negative 4. So when you plug negative 4 in for x, you're going to get negative 4. Plug negative 1 in for x, and you're going to get negative 10. Same thing as if you plug negative 5 in for x. Because that negative on the outside, you have a TP. All right, number 9 on page 11 here. Set 4x, or x minus 4 equals 0. You get x is 4. That y value of the coordinate is 6. Go 1 to the left with 3, 1 to the right with 5, 2 to the left with 2, 2 to the right with 6. Let's plug 5 in. Absolute value of 1 times 2 plus 6 is 8. Plug 6 in. Absolute value of 6 minus 4, that's absolute value of 2. If you double that, you get 4 plus 6 is 10. All right, next one we have some inequalities. This one has a y-intercept of 5, slope of negative 1/2. It's going to be a solid line, less than or equal to. Y-intercept, then you go down 1 over 2, down 1 over 2, solid line. Because it's less than or equal to, you're going to shade below. Should be a pretty easy question for us. Add x to both sides, divide by 2, y is greater than 1/2 x plus 3 greater than means it's a dotted line. Y-intercept of 3, up 1 over 2, up 1 over 2, up 1 over 2, dotted line, you're going to shade above because of greater than. All right, I'm not sure, so on page B, what follows, section 2.8, warm-up, state whether each point gives a true or false statement, write that down. Pretty sure we did this in most of the classes. Anyway, there's number one. You know, pause it if you need to. Basically, there's an inequality and a point. You plug that point in. Do you get a true or false statement? So you might, if you don't have this, you might definitely have to pause it many times here. All right, that is 2 is less than 26, which is definitely true. This one right here, 12 is less than or equal to 12. That is a true statement because of the equality. 0 is bigger than -1. That's true. Here's another true statement because of the equality. This one's false. I mean, you can't really plug 3 in. 4 is not greater than or equal to 6. That's false. That's just a horizontal line. This next one, number 7, and then number 8. So again, if we did this already in class, that's no big deal. If you don't have it, then pause the video and write those down. Okay, on page 13, here we go. I use the cover-up method. Basically set it equal to -24. 6x equals -24. X is a -4. That's the x-intercept right there. And then set 4y equal to -24. You get y is -6. That's the y-intercept. You have a solid line less than or equal to. Now be careful. I would test 0, 0. Plug 0, 0 in for x. And you get... Yeah, you get underneath. And it makes sense. Y is positive, so at least you can, if you assume that you're going to shade under, you're right there. All right, this one here, subtract 3, divide by 2, you get y less than or equal to 4. That is a straight horizontal line. It's a solid line because it has equality, and you're going to shade below. All right, page 14 here. X greater than or equal to -3, put a dot at -3. It's a vertical line. You're going to shade to the right. Solid line there, solid vertical line. Subtract 3x from both sides. You're going to have y less than -3x minus 2. The slope is -3/1. -2 is the y-intercept. Go down 3/1. Dotted line. Less than means you shade under. Again, you could use 0, 0. If you plug in 0, 0, you get 0 is less than -2, which is false. 0, 0, which is above that line, is false. Everything here is false. Everything below is true. All right, page 15. Absolute value inequality. So we're going to make my absolute value table the same before. So what's inside the absolute value equal to 0. Go 1 to the left, 1 to the right, 2 to the left, 2 to the right. Plug those x values in. See what you get for y. Because it's greater than, you're going to have a dotted line, and then you're going to shade above. You're going to shade above. All right, this next one here, set that equal to 0. What's inside the absolute value? 3, 1 is your vertex. Go 1 to the left with 2, 1 to the right with 4, another to the left with 1, another to the right with 5. Plug 4 in for x, you get 2. Plug 5 in for x, you get 3. It's going to be a solid, 2 solid lines there. And you're going to shade below because it's less than or equal to. Guys, on number 3, you need to add 1 to both sides. So what's inside the absolute value equal to 0. You get -2, go 1 to the left, -3, 1 to the right, -1. Another to the left, -4, another to the right, 0. -2, 1 is your vertex. Plug -1 in for x. Plug 0 in for x. You get 3 and 5. So you're going to have another 3 and 5. It is greater than. You're going to shade on the inside. It's dotted because it's just greater than. All right. So here we're going to pause and we'll have the second video for the next parts.